Building Reliable Process Models. Part 3. Introduction to BPMN 2 Shapes. And today it's Activities. With me, Declan Cheller.
This tutorial is aimed at people who are new to process modeling and experienced process modelers who want to take a more structured approach. But first, some symbols. Instructions are indicated by this graphic, handy tips by this one, warnings by this one, quotes from the BPMN 2.0 specification by this one, and pop quiz questions by this one.
This video is a short introduction to the meaning of the activity shapes, but it's not an exhaustive tutorial on how to use them. What is an activity? An activity is work that is performed within a business process. An activity represents the performance of work, and it's the only BPMN shape that represents the performance of work. What do you think the outer edge that defines the activity shape is called? Pause the video if you need to think about it. The outer edge that defines the activity shape is called the boundary. What is a subprocess? A subprocess is an activity whose internal details have been modeled using activities, gateways, events, and sequence flows. A subprocess is a graphical object within a process, but it can also be opened up to show a lower level process. A subprocess is an activity which is broken down into further activities. What is a task? A task is an atomic activity within a process flow. A task is used when the work in the process cannot be broken down to a finer level of detail. A task is an atomic activity, which means that it cannot be broken down into further activities. An activity must sit within one lane. An activity may never lie across lanes. Why may activities not lie across lanes? Pause the video if you need to think about it. We use lanes to organize our model. Laying activities across lanes defeats that purpose and introduces ambiguity. What if the same task is repeated by more than one performer? Pause the video if you need to think about it. If the same task is repeated by more than one performer, we repeat the task in the model. In this example, the leave request must be reviewed at 2 levels, but the review task itself is the same. What if the same task really does require multiple performers? Pause the video if you need to think about it. The same task may not allow multiple performers. You must identify the work to be done by each performer and model one task for each. What if a subprocess has multiple performers at the expanded level? Pause the video if you need to think about it. You put the subprocess shape within the lane which owns the first task of the expanded model. At the expanded level, you allocate tasks to the appropriate lanes. A task is an atomic activity, which means that it cannot be broken down into further activities. It's up to the process modeler to decide where to draw the line. But common sense will tell you that if you have an activity called capture customer details, you're not going to break it down into separate tasks for each line of those details. Non-executable versus executable. Your modeling style will depend on whether you're producing a non-executable or an executable process model. Non-executable. The intent of the model is to understand and describe a business process. It is not meant to inform software designers. Executable. The intent of the model is to define a process to be managed by a process engine. It is meant to inform software designers. Knowing the difference will help you decide what task types to use. Task types. You don't have to indicate the task type, but it adds clarity. User task. A user task is a typical workflow task where a human performer performs the task with the assistance of a software application and is scheduled through a task list manager of some sort. In other words, the process engine triggers the task, assigns it to a user, tracks its SLAs, and manages any rules governing its completion. Manual task. A manual task is a task that's expected to be performed without the aid of any business process execution engine. In other words, the process engine cannot trigger the task, assign it to a user, track its SLAs, or manage its completion. Manual task versus user task. If your process model is not executable, it should not include manual tasks. For non-executable processes, just use a user task for any human task. Service task. A service task is a task that uses some sort of service, which could be a web service or an automated application. How that service is implemented is within the scope of that external system or entity. In other words, the behavior of the service itself is never modeled within the same pool as the service task. Script task. A script task is executed by a business process engine. The modeler or implementer defines a script in a language that the engine can interpret. When the task is ready to start, the engine will execute the script. When the script is completed, the task will also be completed. However, the BPMN specification does not define the word script, so you can use the script task for any atomic task that is to be automated by the process engine. Service task versus script task. If your process model is not executable, it should not include script tasks. For non-executable processes, just use a service task for any automated task. Business rule task. A business rule task provides a mechanism for the process to provide input to a business rules engine and to get the output of calculations that the business rules engine might provide. However, that wording does not forbid assigning a business rule task to a human. After all, the rules behind a business decision are the same whether that decision is executed by a human or by a rules engine. A business rule task executes business logic to determine the outcome of a decision. The business rules themselves should be modeled in a linked decision model and not within the process model. Receive task. A receive task is a simple task that's designed to wait for a message to arrive from an external participant relative to the process. Once the message has been received, the task is completed. A receive task waits for an incoming message from another pool, but it does not process the received message. So it effectively serves the same purpose as a message catching intermediate event. A task represents work being done, which is active. For me, simply receiving a message is passive. No actual work is being done. So I prefer to use a message catching intermediate event. Send task. A send task is a simple task that's designed to send a message to an external participant relative to the process. Once the message has been sent, the task is completed. The send task does not compose or prepare the message. It simply sends it. The work of composition must be done in a previous task. Subprocesses. A subprocess is an activity which is broken down into further activities. Why have a subprocess? Why not just show the underlying activities themselves? We use the subprocess shape to declutter the diagram, or to show the scope of boundary events. Collapsed subprocesses should sit within the lane where the first task of that subprocess is performed, even though subsequent tasks may be performed in other lanes. The details of a collapsed subprocess are shown on another child canvas. But we can also have expanded subprocesses. Note the absence of the plus symbol. However, expanded subprocesses can clutter your canvas, so use them sparingly. The details of an expanded subprocess are shown at the same level as the subprocess shape itself. An expanded subprocess must display its own start and end events, just as it would on a child canvas. A subprocess inherits its pool from the parent, so you're only required to show the pool at the top level of your model, although you are allowed to show the pool at lower levels. However, you may not change pool at the lower level because then you would be inside a different process. Do show any relevant lanes at the subprocess level. Whether collapsed or expanded, subprocesses must have one start event of the type none. Why does the start event of a subprocess not have a type to indicate the nature of the trigger? Pause the video if you need to think about it. This is because the trigger for the subprocess is already known. It's the end of the previous sequence flow at the parent level. Subprocesses must have at least one end event. You must label subprocess end events if there are more than one. Why must you label subprocess end events if there are more than one? Pause the video if you need to think about it. If a subprocess has more than one end event, it means there can be multiple outcomes, and each must be labeled to distinguish it from the other outcomes. It's optional to label a subprocess end event if there is only one. But you can label it if you think it adds clarity. Looping activities. You use a loop symbol when you want the process to repeat the same activity before moving to the next. Standard loop. The standard loop characteristics class defines looping behavior based on a Boolean condition. The activity will loop as long as the Boolean condition is true. The condition is evaluated for every loop iteration and may be evaluated at the beginning or at the end of the iteration. In addition, a numeric cap can be optionally specified. The number of iterations may not exceed this cap. With a standard loop, there's no way of knowing how many iterations are needed when the activity is initialized. Document the nature of the loop in the meta-information about the activity. The format do until x is true is semantically the same as do while x is false. Multi-instance loop. The multi-instance loop characteristics class allows for creation of a desired number of activity instances. The instances may execute in parallel or may be sequential. Unlike a standard loop, the number of iterations of a multi-instance loop is known once the activity initializes. For example, in the process for making an omelette, when we start the task break egg, we know how many eggs we have, and we repeat the task until all the eggs are broken. In this case, it's a parallel loop, which means we don't care in which order the eggs are broken, and if we can break more than one egg at the same time, we're allowed to. We use a sequential loop when parallel processing is not allowed. For example, a restaurant might have lost too many eggs to clumsy staff and have a policy that staff may only break one egg at a time. Reusing activities. Sometimes we want to reuse exactly the same activity in different parts of the same process or even in different processes. In BPMN, we signify reuse with a call activity by applying a thick boundary to the task or subprocess to be reused. A call activity identifies a point in the process where a global process or a global task is used. The call activity acts as a wrapper for the invocation of a global process or global task within the execution. The key point about a call activity is that you reuse its behavior, not just its name. That way, you only need to define the behavior once, and you can reuse it in the same model or across different models. Remember this example from earlier? In fact, because the behavior of the task review leave request is the same for both performers, we should model it as a call activity. Remember I said you may not change pool within a subprocess. However, a global subprocess must have its own pool and its own name, since it does not belong to any particular process pool. What's next? In my next video, I shall cover flows and gateways.
Watch out for my other tutorials on such topics as structured approach to building a process model, when to model decision logic instead of process logic, introduction to modeling business concepts. If you found this tutorial useful, please click like and subscribe to my channel for more. Thank you.